Welcome to my 10th video in our third chapter for our ActionRPG project in Unity. And in this video, we're going to finish the skeleton's projectile attack, because right now the projectile just kind of sits there. And then we're also going to set up the skeleton's unique death animation, because right now the skeleton dies in a puff of smoke, which is exactly the same thing the slime does when it is defeated. But the skeleton actually does have a animation for crumpling apart and falling to the ground. So let's take a look at changing how enemies might end up dying in the game, which will kind of give us a lot of flexibility down the road for enemies that just may turn into a puff of smoke or enemies that have a death animation. So that's going to take us to the skeleton script first. So let's open this up and take a look. So we've got a lot of like our update method here. We've got our fixed update for movement. We've got our attack method, but we want to start thinking about changing the check health method. So jumping over to enemy and scrolling towards the, I believe that's under health and damage. So we have this check method that spawns a puff of smoke and then deletes the object. Well, if we want to replace that, similar to what we did with the attack method, how that was able to be overridden in the child method, we can do something similar. Some polymorphic behavior is what this would be called. So the first thing we want to do is tell the compiler that check health can be overridden by a child, and that's giving it the keyword virtual. That won't affect anything. That's not going to affect how Orange Blob treats the method, because Orange Blob doesn't have its own unique version of check health. It's just using enemies. But Skeleton is going to replace it, and we do need to give it that keyword virtual to let it know that we can replace it, kind of like what we did with update. Secondly, I guess let's get the naming convention fixed, because we've been naming stuff with capital letters for methods. So if we go to this little thing here, fix name violation, we can actually click on that, and it will go through, and any place that this was used, it will fix it. So it really just changed it in late update. So it's capital C check health now. So let's go to the skeleton, and right after the attack method, let's add a protected override void capital C check health. And this allows us to just completely replace the behaviors inside of check health, because we don't want it to appear into a puff of smoke. Instead, we want to disable pretty much all the scripts and just play the death animation. So if health is less than or equal to 0, let's first restore the skeleton's color, because in case it was in a hit animation. And so we will access the sprite render.color, and we're going to set that to color.white. Then we're going to take the set bool on the animator, is hurt will be set to false. I guess that won't, I think the death trigger is going to override that anyway. And then animator.setTrigger death, so that the skeleton will begin its death animation. Then after we do all of that, we're going to want to configure the facing of the skeleton before we completely disable it. So we don't know which way the skeleton might be facing, but if there was a target, if target is not equal to null, we want the skeleton to face that target before we disable all of its AI. And I'm just going to steal that from this update, fixed update, this part here where we have attack animation if target is not equal to null. I'm just going to steal those two lines. And then disable components. We're going to go through and disable pretty much everything that's like useful. So get component enemy. We're going to turn off the parent enemy script. So .enabled equals false. That'll disable the AI from updating and all the move methods. Get component skeleton .enabled equals false. We're going to disable all the skeleton stuff so it doesn't try to activate check health more than once. We're going to turn off its collider. so that it no longer participates as a collidable object. And then we're also going to disable its rigid body. So like if it was sliding, it would just stop. And rigid body actually doesn't use enabled, it uses simulated. And so all of that should override how the normal enemy handles its check health method. So the skeleton has replaced the default one, which was really just 2 lines of code. It would make a puff of smoke and delete itself, with this version. So let's minimize that. And let's see if this actually works. Assuming I didn't make any typos, it should. So we come back into Unity, it compiles, and the skeleton, I mean, we won't know until it dies. So it, properly tracks us. We hit it, takes 4 hits to kill it, and then it goes into its death animation, and you can see that it's not continuing to face us. We can't strike it anymore. So for all intents and purposes, it has been removed from the computation of the game. So like if we click on skeleton, we can actually see its collider got turned off right here. We can see that the skeleton script got turned off. That could be dangerous if you're trying to grab its name, but I don't really see any harm in that. And so all that looks pretty good. Our skeleton is properly going into its death animation, and boom. So next up is to get its projectile to actually do something interesting. So we've got this bone. No, we don't have it in the world yet. So let's take this bone pixel projectile, and I'm going to just kind of break it into its own, into a new prefab. So I'm going to drag and drop it down here into enemy, and it wants to say, what do I want to do about this prefab? Thanks, Unity, on GUI drag before. We want to actually make a original prefab out of this. If you choose original prefab, it breaks its old link, and now it's a brand new prefab. And so this bone is no longer associated with this bone, because this is the one we're going to modify. I'm going to rename it as well to skeleton projectile. I'm going to delete this. So skeleton projectile is now its own prefab, completely unconnected to the one that we dragged it from, and that way we can always just use these again to make new things, which could be useful. So let's go into our scripts and create a new script. And we'll call this skeleton projectile. Actually, probably could just call it enemy projectile. I don't think there's anything specific to the skeleton about it. Alright, so let's open up enemy projectile. And, ooh, I have to name it, and I forgot that golden rule. So, yeah, we're going to have to close that. We can't have names in scripts. So take that name out, and then when we reopen it, we have to reopen it because Visual Studio will lose track of it because we renamed the file. But if I close it out like this and reopen it, we will never even notice that we had to rename the file. But you can see now it doesn't have a space in it. Okay, so we've got this, and we want to make it into just a projectile that does stuff. So let's set up some variables. We could even, I don't think we need to make categories. So the first one that we're going to do is the move speed. So, and my recommendation here is greater than or equal to 7. And so that's going to be public float move speed. Let's go for 8. Then let's add a public int damage. How much does this projectile hit for? 15. I don't know, that's kind of, if you want to make the projectile, it's pretty short range, so the skeleton's only going to be spamming it when it's close to you. Then we need a knockback value. And I think those slimes knockback is like 4, so we can maybe make this something like, I don't know, 6. Anything over like 20 is pretty like ridiculously not fun. My cat agrees with that. He doesn't think. Large knockback things are very interesting. So this is our offset. So this is going to be our public float offset. And this is going to determine the stacking order. So if we recall negative numbers, we can go look at what we put here. Positive numbers make this more likely to be behind things. So negative numbers make it more likely to be in front of things. And it's a floating projectile. So now we gotta go through and do our components. So we need our rigid body. Then we need our collider. Collider is like a built-in name, so that's why I end up calling it my collider. We're going to need the animator. And then sprite renderer. So many different components here. And then lastly, if we're going to need it, we could do a movement vector. And so that would allow us to store any sort of like movement to it. That could be related to like moving in a direction other than that it's facing. So inside of start, we want to connect all of the components. And so this is the usual. I mean, honestly, at this point, we could probably just pull it out of enemy. We've done this so many times. So body equals rigid body, sprite render equals sprite render, animator equals... Oh, did I spell that wrong? Oh, I call that animation. So that's why we copy and paste things. And then lastly, we need to do the my collider. And it's a collider 2D, so it could be a circle collider, ellipse collider, box collider. We don't know what it is, but it gets whatever collider we have on here. So the update, this is where we're going to redraw the stacking order. So I'm just going to take that from the enemy as well and paste it in here, where we set the sorting order to 30,000 minus this computation. And now we're going to start setting up the actual hitting the player logic. And that's going to be an on trigger enter. So we need private void on trigger enter 2D. And like I said, I usually rename this thing from collision to other because I think that makes more sense. So if other dot compare tag is a player, then this is the code for where it hit the player. Gotta put my comments there. So if it hit a player, we need to calculate our force of our hits and then apply it. So realistically though, we could probably take some things out of here, like this, where we calculate some of this, and let's just take that. So I'm going to copy this out of the point blank area effect attack. We're going to go into enemy projectile and put it here. Except for it's not called item, it's actually called other, so we do have to rename that. So with those renames, and then we're not using melee attack knockback, we're just going to use the variable called knockback. And we're going to use damage here. And then to kind of set up its stuff, we'll run a method that we haven't programmed yet called impact. Much similar, very similar to how the player fireball works. If we recall, we had this impact method where we did some of these things here. We're going to be doing a very similar thing to that. So if it hits a player, get the script to the player, calculate the force of the knockback, and then send the message for the damage. Then we're going to do if it hits like a tree or a doodad. So if other.compare tag is a doodad, so like those trees and such. I believe we, in our doodads, we had a method here called isTall, and it determines if it blocks a projectile or not. So if it's touching a tree or whatever, let's get our doodad script. And we need to check to see if it is a tall doodad. So if script.isTall. If so, initiate impact. And then lastly, and this is just checking to see if it's like a cliff or something. So if other.name is equal, or let's go with name.contains blocking. If you recall, that's what we called blocking high and blocking low. And so the projectile is probably going to need to exist in the sky layer, or whatever we called it, so that it doesn't collide with water. Going back to kind of how we had set up that physics. So if it hits like a blocking layer that it would have even collided with, it goes into impact. So those are the only cases we're worried about. It hits a player, it hits a doodad such as a tree, or it hits a blocking layer. So the method called impact now. Let's set up some behavior. So the bone itself just spins. But when we looked at it in the previous videos, some of the other projectiles, such as like the firebolt, actually does have an animation. So the firebolt did have a animation for hit. So it can switch into a hit animation. There's its traveling animation, then when it impacts, it does this. So it could be worth our while to actually configure this script to be able to switch between types where it just disappears or it actually has an animation where it finishes its thing. The bone, however, does not. The bone doesn't have an impact animation. So we just want it to just disappear, basically. So going back to this code, let's go add one more tooltip. And so the bone does not. So we'll call this public boolean has impact animation. We'll default that to true because most of them actually do. It's just the bone does not. So we can at least kind of set this up so that we have the capacity to do either technique. Additionally, if we're going to model this off the fireball, we do need a variable called active, because if you recall how we set up the fireball, we use this active variable to control some stuff. Calling it is active. I know we already set it up in the instance variables, but there's no harm in putting it inside that start. So, going down to our impact. So if it's just a simple bone, so if has impact animation, what was the other one? Earth Bolt. And Dark. Actually, Dark Bolt doesn't, if I recall. So those are the two that don't have impact animations. You could obviously check. So if it does not have an impact animation, all we really want to do is just destroy it. This .game object, assuming I can type. And we don't need to do anything else. But if it does have an impact animation, let's call animator, and then we'll set trigger impact. And then we can call my collider .enabled is false. We'll turn off its collider so it no longer like registers hitting things. If is active will be set to false. And to be on the safe side, we can actually do the destroy command. And we can tell it to destroy this after like 1 second. And that's just in case the animation fails to call a destroy trigger. So that way we can at least have this bolt kind of work for two different cases, depending on if it has that animation or if it doesn't have that animation, which will make this look, really kind of nice, actually. So now let's kind of set up a few things for the when we need movement. So we need our fixed update. Oh, auto completes. All right, so fixed update. If is active, we are going to do kind of just the lazy body.move position, transform.position plus transform.right, which is the forward vector for something like this, times move speed times time.delta time. So this is like a non-physics movement. It's really pretty lazy, but it gets the job done. And then lastly, we need a public void delete. And this we'll just call destroy. And that's for the animation to optionally call that, so that if we need to delete this, we can have the animation do that. Okay, so with that saved, we have all the tools that we need in order to correctly do this. Now, we could tune this up, this impact here, with setting it to delete after 0.1 seconds. We can actually go look at the animations. So if we go look at like a firebolt, I know they're all set to be the same duration. So these things run for half a second. So we probably could just go through and we wouldn't even need the animator to call it. We could just tell this thing to delete it after 0.5 because all the animations are set to do that. So we wouldn't necessarily need the delete method. It can do a delayed destroy, which is convenient. Let's go and make sure that those animations for the projectiles, though, the impact ones are set not to loop. So let's uncheck loop time on all the impact animations so that they don't like restart or anything. And that will keep it from looping through that hit effect, which would look really silly. All right, so enemy projectile is pretty much done. So let's go to our prefab for my skeleton projectile, and let's attach this enemy projectile script to it now. And we should be able to hit. Oh, do we need to go? Oh, we have a typo. Oh, my parentheses for the tooltip was misaligned. All right, and that will then cause all this stuff to show up. So that's fine for all these defaults. This does not have an impact animation, so we do want to uncheck that. Otherwise, it will probably bug out. But yeah, that skeleton projectile looks good. So we can now go to our skeleton and have it, instead of throwing a bone, it's going to throw a skeleton projectile now. A properly set up projectile. And so now we should have the skeleton throwing an attack at us that will actually hurt and disappear. Oh, missing component. Let's take a look. It is saying that it's missing. Oh, we forgot to actually attach all of the useful things to it. So open up our skeleton projectile. And this is actually very easy for us to fix. So we need to give it the important things that it's going to need to have. So it's going to need to have a component, physics 2D, circle collider, and then we can decide if we feel like that is big enough. I feel like that's probably too big, so I'm going to drop it to maybe 0.2. Seems a little bit fairer. And this one is a trigger. I don't want it to be like a solid object. It's just it senses something and then does something. And then we need a rigid body. Rigid body is simulated. None of these other things are particularly useful. Maybe freeze rotation is kind of important. Gravity scale 0. It doesn't. It's because it's a trigger. Its mass and stuff doesn't matter. And then that looks good. And then switch it to being on the air layer so that it ignores water for collisions. All right, and now it should properly throw a thing at us. And so we take a pretty healthy amount of damage from that, and it even has little kind of animation as it goes. We could consider maybe one last thing to put into it, similar to what we did with the player, is a max range for it. Because right now it does have infinite range. The barrel doesn't protect us, but this tree over there, which I do recall is a, and I think that's an is tall doodad. Poor skeleton. He doesn't have the best pathfinding AI. So this tree does block things, so it should block the skeleton's projectile if he throws it at me. And we can see that it does. But yet the stump will not, because the stump is not considered to be tall. So that looks good. The only thing left to do is maybe consider putting a max range on these projectiles, because that does seem a bit of an oversight for it to have infinite range. So let's take a look at how we did that for the player fireball. We just had this thing called range, so let's just steal that variable. And I'm going to add it to right after knockback. I do feel like the skeleton, I don't know, the player should be allowed to outrange it a little bit, so let's drop its range to 7. And then what we did for the player's fireball is we did have to track a starting position so that we could figure out how far it's traveled. So we're going to put a starting position variable inside of here. Inside of start, starting position will need to be set to its transform.position so that it records where it started from. And then we just used an if statement during update to check to see if it has exceeded that range. So we'll just, right after this, we'll add if its position, the distance from its position to where it started is greater than its range, and it is currently active, we're going to run the impact method, which, depending on what happens, it just either just destroys it or causes it to do its animation. So that will then make our skeleton's attack not infinite. And that's going to pretty much wrap up our skeleton at this point. So we've got a good host of enemies for us to battle with, a variety of different styles. We've got ranged enemies, we've got melee enemies, and from there you could go through and kind of make your own. I feel like skeleton probably needs a little bit more range. And so you have your own host of enemies. I am going to bump its range up. Let's go with 5. You can see that that does drastically increase its range. And so you have a bunch of enemies. So in between our next series of videos, I am going to populate the rest of the level with enemies so that my different screens have enemies to begin some like persistent thing like respawning enemies, keeping enemies dead, and having some kind of persistent states like switches and doors. And so that's going to wrap this up. There will be a few videos following this for some extra details such as floating damage numbers and sound effects. But if you were to skip those videos, it would not impact the outcome of the rest of the project. They're just kind of cool things that will make this even better than what it is now. So thank you for watching, and enjoy having your two types of enemies. You've got a ranged and a melee enemy.